Good afternoon, students. Welcome back once again to the mathematics class. So, in today's lecture, we are going to study homogeneous differential equations, right? So, here basically a differential equation is said to be homogeneous in either two aspects, right? The first order differential equation is said to be homogeneous if it may be written where f and g are homogeneous functions of a same degree of x and y. Let's see first homogeneous equation definition. What it says: a function f of x comma y is said to be homogeneous of degree n if f of lambda x into comma lambda y, which is equals to lambda to the power n f of x comma y for any non-zero constant lambda. See, here homogeneous differential equation means a function. You can take any function. In general, f of xy we are considering here with respect to the definition of a homogeneous differential equation. A function f of xy is said to be homogeneous of degree n. In general, we are considering n. It may be 1, 2, 3, it may be anything. But in general, a standard form is of degree n. If f of, in place of x and y, we are replacing it by lambda x and lambda y. When by taking common, then what we get here? Lambda to the power n f of x comma y as a function as it is. Again we get the same function for any non-zero constant lambda. It is a non-zero constant lambda, right? Lambda is a non-zero. It is not a non-zero constant, right? So it must be some value. So next we will see some example based on this. For example, f of x comma y, which is equals to y square plus 3xy is homogeneous function of degree 2. We are telling degree 2, right? Let's check whether it is degree 2 or not. Here the y term contains its degree is 2, power is 2, right? And similarly in the second term, x and y both are in a product form, therefore 1 and 1 2, right? Its power and its power, 1 and 1 is 2, therefore here also 2 is there, in the second term also 2 is there, therefore it is a homogeneous function of degree 2, right? Let's check whether it is homogeneous or not once again, because f of lambda x lambda y, which is equals to, just substitute here in place of y lambda y in place of x lambda x, right? So lambda y whole square plus 3 times of lambda x lambda y. Now here taking lambda common, what we get here, lambda square common from first term and as well as from the second term. It is nothing but lambda square is common if we take outside. Inside what we get, y square plus of 3xy, which is equals to what? Lambda square, the function f of x comma y, this is y square plus 3xy, which is equals to what? Function f of x comma y, therefore it is of degree 2, right? F of lambda x comma lambda y, if we substitute in place of x and y, Then finally what we get here? In general we are taking here lambda to the power n, right? So here particular we are getting that the value of n is 2, therefore it is of order 2. It is a homogeneous of order 2. Next we consider one more example. It is first one, it is second one. Let's see in this example f of x comma y, which is equals to sin x plus cos y, is not homogeneous function, we are saying. Why? Let's see. If it is not homogeneous means how? Now again substitute here in place of x and y, it is lambda x lambda y. So sin lambda x plus cos lambda y, which is not equals to lambda to the power n f of x comma y. Can you take a lambda common here? No, you cannot take. It's a function. Sine for trigonometric functions are there. So it is not equals to lambda to the power of n f of x comma y for any n. You can take for any value n, right? So next, one more type of method is there to identify whether it is homogeneous or not of degree. In general, n we are taking here. So next we will see the observation, one more observation. See, f of x comma y, which is equals to y square plus 3xy. We can solve like this also by using this method also. So here just by taking x square common, to converting in the, it is in the form of y by x, right? By taking x square common, what we get here? Y square upon x square plus 3 times of y by x. X get cancelled, right? So what we get here? X square g of y by x, or which is equals to, if we take y square common from this equation, then what we get? 1 plus 3 times of x by y, which is equals to y square. This term can be written as h of x by y. So thus f of x comma y is homogeneous function of degree n if if f of x comma y, f of x comma y, which is equals to x to the power of n g of y by x, or y to the power of n h of x by y for any n, right? So again, it is a one type of a differential equation, homogeneous differential equation, to check whether it is homogeneous or not, of a, which degree it is exactly. So similarly, next one more example. Its next definition we'll see. Here a differential equation in x and y is said to be homogeneous, is said to be homogeneous if it can put, if it can put in the form, in the form dy by dx, which is equals to f of x comma y upon g of x comma y, right? where f of x comma y and g of x comma y are both homogeneous of same degree. Homogeneous means here of same degree of both homogeneous function. Homogeneous function of same degree. Same degree in x as well as y. In the numerator as well as in the denominator we get of a same degree. Then we can say it is a differential equation of same order in terms of x and y, right? Let's see the working rule how to solve this. To solve homogeneous differential equation, first type we will see. It's first one. To solve homogeneous differential equation of the type dy by dx, which is equals to f of x comma y, then what we can do, if the differential equation is in the form of dy by dx which is equals to f of xy, then take it as it is equation 1, put y equals to vx here, right? Y equals to vx when it is dy by dx form, right? Put y equals to vx, that is y by x equals to what? It is equals to v, so that dy by dx, if we differentiate this, what we get? Dy by dx, which is equals to given to v formula, first function as a differentiation of second function, that is x is 1, plus second function as it is x as it is differentiation of first function, that is dv by dx, right? Now from this equation 1 becomes v, just substitute in equation 1 these values, dy by dx value and this y value as it is, right? What it becomes, v plus x dv by dx which is equals to g of v, right? Again, which implies what we get here, x dv by dx. Take this plus v to the RHS, it becomes g of v minus v, right? So now variable separable. Now already you know well, in the previous lecture we have studied variable separable. So if we variable separable, if we did means what we get, dv by gv minus of v into dv as it is here, which is equals to dx upon x. It is nothing but variable separable. Next, integrate this. After variable separable, already you know, we can integrate it. Integrating dv by gv minus of v, which is equals to 1 upon x dx, which is a required solution of 1 when you replace it by when we replace v by y by x. What we have substituted initially, just we have to replace it v by y by x, then we get it's a solution. It is one type when dy by dx equals to f of xy. If case 2, second type, when the homogeneous equation of the form dx by dy. Initially it was dy by dx. So here dx by dy, it is h of xy. Earlier that was dy by dx, which is equals to f of xy. Here what you can do here put x equals to vy. There what we have done, y equals to vx we have taken, here x equals to vy. Therefore x by y equals to what? V. And proceed as above. Just substitute and differentiate this x with respect to y, that is dx by dy. We get again u into v form here, and again substitute in the equation 1 and simplify, take variable separable and integrate it. Finally we'll get a differential equation, finally replacing v by x by y, right? Let's see one example. Based on this we will get more clear. First example, show that dy by dx, which is equals to x minus y upon x plus y, is homogeneous, and solve it, right? Already they are telling it is homogeneous, so just we have to solve this by using homogeneous definition. Solution: let us consider the given equation, that is dy by dx, x minus y upon x plus y is there, take it as equation 1. Now it is in the form of dy by dx, which is equals to f of x, right? So here just substitute. Let's check whether it is of homogeneous of which degree. It is f of lambda x lambda y, which is equals to, or you can take this dy by dx, which can also we can write f of x comma y, which is equals to x minus y upon x plus y. So we can simply similarly in place of x and y we can write f of lambda x comma lambda y, which is equals to lambda x minus lambda y on lambda x plus lambda y. By taking lambda common from both numerator as well denominator, what we get here, again here lambda lambda get cancelled, which is equals to lambda to the power 0 x minus y upon x plus y, which is equals to lambda to the power 0 the function f of x comma y, right? So lambda to the power of 1 is nothing but it is 1 only. Lambda to the power 0 is 1. Therefore x minus y, x plus y, therefore we are taking the order is 0 here, right? So thus the function f of x comma y is homogeneous function of degree 0, right? So now put y equals to vx, because it is dy by dx is there, right? Y equals to vx, take it as equation 2, so that after differentiating what we get with respect to x, dy by dx, which is equals to first function as it is, differentiation of second, that is x is 1 plus x as it is, dv by dx. Just you can remember it, don't always try to differentiate every time, just you have to remember y equals to v of x and dy by dx, which is equals to v plus x dv by dx. Simply you can write it directly. So now substitute it in equation, take it as equation 3 here. From 1 using 2 and 3 we get, from 1 using 2 and 3 we get v plus, just substitute here, in equation 1, dy by dx value is v plus x dv by dx, which is equals to x minus vx upon x plus vx. Just we have substituted y equals to vx again, which implies v plus x dv by dx. Here by taking x common, 1 minus v, 1 plus v, x get cancelled. So what we get here, x dv by dx 1 minus v upon 1 plus v. This plus v take on RHS, it becomes minus v, right? Next I will write here. So again, which implies, which is equals to, now cross multiply this x dv by dx as it is, which is equals to, if we cross multiply, what we get, 1 minus 2v minus of v square upon 1 plus v, right? Just we have cross multiply 1 plus v minus 2v. So which implies again 1 plus v, now variable separable, 1 plus v upon 1 minus 2v minus v square into dv, which is equals to dx upon x. It is nothing but variable separable, right? So now integrate after variable separable. Integrating with respect to x, we get integration of 1 plus v upon 1 minus 2v minus v square into dv, again 1 by x dx, right? So now here we are multiplying and dividing by minus 2. Let's see what we get. Minus 1 by 2. Why we are doing minus 2? Multiplying and dividing means to convert it is in the standard form. It is derivative of f of x upon f of dash, f dash of x, right? So the standard formula is there. To convert in that form, we are multiplying and dividing by minus 2. It is minus 1 by 2 outside. Inside minus 2 means what it becomes? Minus 2 minus 2v upon 1 minus 2v minus v square into dv, which is equals to log of mod x plus log of c, right? So now, which is equals to minus 1 by 2. Again here what we get directly now? It is log of 1 minus 2v minus v square, which is equals to log x plus log c. So again, which is equals to minus 1 by 2 log of, just substitute the value here, v value 2. V means y by x minus v square means y square by x square, which is equals to log x plus log c. Next I can write here, continue, again which is equals to, again which is equals to minus 1 by 2 log of, now cross multiply by taking LCM, what we get here, x square minus 2xy minus y square upon x square, which is equals to log property. If we apply means log m plus n can be written as log mn, right? So similarly, if I take minus 1 by 2 to the RHS, it becomes log of x square minus 2x minus y square upon x square, which is equals to log of, when I take minus 1 by 2, it becomes here minus 2. If I take logarithm property, it becomes cx to the power minus 2. Then if I write log 1 by c square x square, right? So again, which is equals to, here both side log get cancelled. Remaining term write down as it is, x square, which is equals to 1 upon c square x square. So again, which is equals to x square minus 2xy minus y square. Here x get cancelled. Only c square remains RHS. So again, which is equals to x square minus 2xy minus y square, which is equals to a, where a equals to 1 upon c square is an arbitrary constant, right? Which is nothing but our required solution. X square minus 2xy minus y square, which is equals to a. Let's see again what we have here. Order 2, x square xy y square, right? So it is nothing but required solution of homogeneous differential equation. So some more example we will see in the next lecture. Till then, take care, stay at home, stay safe. Thank you.